Hi, Hiram. Can you hear me?
अरे सुनाई
Hiram?
Yes, Dr. Someshwar.
You can hear me, right?
Yeah, I can hear you. We were just checking with Dr. Uma whether she's able to speak, and
Yeah.
I think Dr. Christos is.
Dr. Christos has joined.
Yes, I have.
Hi, Dr. Christos. Good to see you again.
Good to see you again as well.
Yeah. So Dr. Lena Patel already joined. So how are things with you? All well?
Yes, thank you. Can you hear me all right?
Yes, yes. Loud and clear.
Fantastic.
So we're scheduled to go live in 4 minutes. So we wait for some time participant to join, then we can go online. So we'll have a hard stop at 4:30 p.m. IST. So we already informed the chairperson. You want to test your slides once?
Happy to.
Yes, we can see it.
So do you see the presenter's view, or do you see full page of the slide?
We actually full page.
You see the full page. Fantastic.
Yeah. So can you move a couple of slides?
Yeah.
Yeah, going well. Perfect. Perfect. I think Dr. Lena Patel is already here. Amit, Dr. Lena Patel also needs to be co-host. Please make her. Hello, madam. Good afternoon.
Hello, Dr. Patel.
Hello, Dr. Christos and Dr. Someshwar.
Hello, madam.
It's good to see you again.
I have a very bad throat today somehow,
Oh,
Oh,
but that's okay. Most of the talking is good. It's fine.
hi, Miranda.
Mute.
Hi,
Hi, everybody.
mute.
I'm a little
Yes.
bit late to join. Hi, Dr.
No,
Patel.
you're just on time. Just on
hi,
time.
Miranda.
Hi.
So we still have some participants to join, Miranda. So maybe in 3 to 4 minutes we can start.
Get my phone. That's okay. They'll put it here. Email myself.
I'll just follow up with my team, Miranda. Just allow me a couple of minutes so people can join in. Hiram, are you there? Hiram?
Yes, Dr. Someshwar.
Can you follow up with our team?
Yes, I'm following up. Yes.
Okay, yeah, please send a reminder. Okay. Yeah, thanks. Madam, we'll begin at 2:35 in just next couple of minutes. Dr. Christos will begin in just couple of minutes.
Thank you.
Yeah.
Hi, Dr. Shubhendu. Good afternoon. Good afternoon to you. Yeah, so we can see you and hear you. Thank you, sir. We'll be starting in a couple of minutes.
Good afternoon, sir. Welcome. Thank you for joining.
Thank you.
We start in next one minute. So, Madam, we will start with the permission.
Yes, please do.
Yeah. So, I hope you can see my slides. Hiram, can you confirm? Can you see my slides?
Yes, I can see your slide.
Yes. Thank you. Thank you. So, hello everyone, and a very warm welcome. On behalf of my entire team of MOR, I, Dr. Someshwar Raisam, I welcome you all for this unique EKTL program by Merck. The objective of this program is to enable our Indian fertility experts to meet and interact with an international fertility experts for addressal and clarification of all their queries and doubts around troubleshooting in ART. So today we have with us Dr. Lena Patel, who will be our honorable chairperson and moderator for the day. And we are also joined by Dr. Christos Benetis, who would be our keynote speaker for the day and international expert. We also take the opportunity to welcome our original medical director, Miranda Hike, who has joined in from Australia.
I think Someshwar has frozen. Does anybody else have a frozen screen?
No, I think Someshwar is frozen.
Yes.
Yeah.
Okay, so who's controlling the, Christos, are you controlling the slides yourself?
Because there's something
I can control my slides, but not the slides that's, so measure.
Okay, I'm wondering if
I
we
think
should.
probably he will rejoin soon, Miranda.
Okay.
Maybe we should wait for a minute.
Yeah, so Miranda, so much for joining again.
Yeah.
Okay, no worries.
He joined.
I was going to try and weave some magic, not quite worked out what that magic was yet, but
I'm pretty sure it would have been great.
Otherwise, Bharat, we could perhaps kick off if you have the slides.
Yeah, I think so. Someshwar is frozen. I don't know, he's not connected.
Yeah.
Should we start introducing Dr. Christos and start the event?
Yes, let's go ahead. So,
Yeah,
Dr.
yeah.
Christos,
I
all
think
right,
so.
over to you if you'd like to introduce Christos.
Yeah, so there was some. I don't have the slides right now, but I think so. Let me just check. I will just give me a 1 minute time. At least I will introduce the participants, and then Madam can start introducing our speaker, today's speaker.
So, Bharat, are you taking care of going around the room here, or shall I?
Yeah. Just a minute. I think so much already joined.
Yeah, so message just joining.
Yeah.
Oh, okay. Yeah, he's back. Hi, Smash. We're back. We're waiting for you. Thank you. You're here.
So much you're on mute.
Yeah, I'm so sorry. I had a power outage, so I just connected through a hotspot. I'm so sorry. So
No worries.
I'll join again. Yeah. So can you see my slides again?
Yeah.
Yes.
Yeah. So continuing that. So we also welcome our medical director from APAC region, Miranda Hickey. She has joined from Australia. Welcome, Miranda, and thank you for joining. And
Thank
for
you,
the
Smash.
and coming to the agenda for the day, after setting of contributor Lena Patel, there would be a lecture on the topic of the case of phototropic alpha oriented versus biosimilars by Dr. Christoph Benitez. And it would be followed by local experience sharing session, but Dr. Lena Patel on the same topic. And after that, the session would be opened up for open discussion on Q&A and troubleshooting in ART, where participants are free to ask any questions and any doubts pertaining to the ART cycles and IVF and ICSI cycles, and their address, the queries and doubts would be addressed by Dr. Christoph Benitez and Dr. Lena Patel. And today we are joined by a group of elite fertility experts from all over the India and neighboring countries. So today we are honored to be joined by Dr. Lena Patel from Anand, Gujarat. We also joined by Dr. Pratibha Makhija from Bilaspur, Madhya Pradesh, Dr. Palak Gowri from Raipur, Dr. Patnaik from Rourkela, Dr. Roshni Ji from Eluru, Dr. Shiva Tripathi from Varanasi, Dr. Anchal Agarwal will be joining us soon from Delhi, Dr. Anupama Ravi from Rudrapur, Dr. Uma Bansal has already joined us from Thane, Mumbai, Dr. Sachin Zadho from Pune, Maharashtra, Colonel Dr. Subindhu Pandit has joined us from Delhi. Dr. Giridhari Sharma would be joining us soon from Pokhara, Nepal. Dr. Thilina Sanjeeva Palihadana will be joining us from Colombo, Sri Lanka. Dr. Nikita Lahadas will be joining us from Mumbai. Dr. Avani Pillai would be soon joining from Kochi. Dr. Pratibha Govindaya from Bangalore. Dr. Rashmi Yogesh from Bangalore and Dr. Vinod Kumar and from Bangalore. So we welcome all the participants who have joined in on this busy working day. Thank you very much. Now, without any further delay, I have to welcome and take the opportunity to introduce our honorary chairperson for the day, Dr. Lena Patel. Dr. Lena Patel is the medical director of Akansh Hospital and Research Institute in the Anand city of Gujarat, India, and she is a person who needs no introduction. She is a pioneer in the field of IVF and surrogacy in India, and she has delivered around 1584 surrogate babies till last year at her center. And she was a past president of State Society of OBGYN in the 2010. And she is the founder president of Gujarat chapter of ISAR. Dr. Lena Patel has been awarded with the award of Dr. Shobna Ben A. Chowdhury Trophy in the past by IMA Gujarat for her best social work in medical practice. And Dr. Patel was also invited at the Oprah Winfrey Show, Heart Talk, TED Talks, and Josh Talks in the past. Dr. Patel runs Anand Surrogate Trust, Saroma, and SRT IVF Charitable Trust, which works for the well-being and betterment of surrogate mothers, their families, and IVF patients. Dr. Patel also authored publication LH and FSH Synergy, a role in COS with all other international fertility experts and eminent doctors. Dr. Patel is an honorary advisory board member for Merck. Dr. Lena Patel is a much sought after speaker in the various conferences. She has delivered lectures at various conferences, and she has authored many research articles, case reports, book chapters, and various textbooks. Her current interests are regenerative medicine, gut microbiome, ovarian and endometrial biomarkers, and PCOS. The documentary is entitled A Womb of the World on Dr. Lena Patel was telecasted and National Geographic Channel. and House of Surrogates was telecasted at BBC. So with this, I welcome Dr. Lena Patel and I request her to set the context and welcome our speaker for the day. Thank you. Thank you for joining.
Thank you, Someshwar and Merck, for having this webinar and keeping me as a moderator over here. I know it is very, very important to understand today's topic, because whenever we do an IVF and we are told that the egg quality is not good by the embryologist in a young patient, we really start scratching our head, where did we go wrong? And the first thing is we would want to look at the stimulation that we did. And all people who come for training are interested in how do we stimulate for IVF for the best oocyte. And so Dr. Christos Venetis over here is going to talk on this today. He is the associate professor and at the University of South Wales NHMRC fellow. He is also the global head of clinical research, Virtus Health, and he is the director of the clinical research IVF Australia, consultant gynecologist and fertility specialist. His research has attracted more than $1.5 million in funding in the last 5 years. He's named the top 1% of most cited researchers worldwide in obstetrics and reproductive medicine for 2020, which is really commendable. He's an author of more than 100 publications in international scientific journals. And he has been a member of the editorial board of Human Reproduction since 2008, and also currently a section editor for RBM Online, Reproductive Biology and Endocrinology, associate editor for Reproductive Sciences and for Fertility and Reproduction. His interests are ovarian stimulation, endometrial receptivity, reproductive epidemiology, and also the health of the mothers and babies after ART, which is very, very important. He's currently leading a number of research projects in these fields, both nationally and internationally, and is mentoring junior colleagues right now. So welcome, Dr. Christos. I'm sure all the participants, I welcome all of them, would really have a lot of benefit after listening to you right from ovarian stimulation to the babies in ART. Welcome, Dr. Christos.
Thank you. Thank you, Dr. Patel, for your warm welcome and your kind introduction. And obviously, I would like to thank Merck as well, for Merck India, for their invitation to be part of this very, very interesting educational meeting. It's always a great pleasure to be even virtually in the company of my Indian colleagues. So I would like to start by sharing my slides. And today I have been asked to present to you some work that we've recently completed and published. And it's, of course, on the case of folitropin alpha originator versus its biosimilars. And to what I'm going to be talking about is the potential differences that RCTs alone cannot reveal. So these are my disclosures. And I would like to start just by saying that, as we all know, in modern day, probably in some countries exclusively, but in many other countries, in the majority of cases, ovarian hyperstimulation is performed predominantly through gonotrophins. And I'm pretty sure many of you know the story that gonotrophins were actually introduced in IVF in the early 80s by Howard Jones and, importantly, by Georgiana Jones, his wife. And they were the ones essentially responsible for what we are doing today in terms of ovarian stimulation. And as a result of that modification, Elizabeth Carr was born a few months later, which, again, I'm pretty sure you all know, was the first baby to be born in the US from IVF. So this is a slide that you all have seen, and it just shows and showcases what we're actually doing with ovarian stimulation. We're rescuing follicles from atresia that otherwise they would have, they would be their normal fate in their normal physiological cycle. And that is why many colleagues actually suggest that ovarian stimulation might not be a proper name. What we're actually doing is follicular rescue. And when someone would ask, why are we stimulating the ovaries? Well, again, many publications have already clearly demonstrated that the more oocytes you have, the higher the chance of having a baby after a fresh transfer, but also a cumulative live birth rate, which is what we define these days as having at least one live baby from a single egg collection. So we're now in the era of ovarian stimulation using gonolotrophins. And as I said, I fully acknowledge that in many countries around the world, due to cost or due to other reasons, ovarian stimulation is not exclusively performed with gonolotrophins. But I think we would all should accept the fact that in the majority of the cycles performed worldwide, gonolotrophins have a central role. This is a bit of a history, and we all know how LH and FSH were discovered in the late 20s, and of course we all have heard the story about the Italian nuns and how urinary gonolotrophins were isolated, developed, and started to being commercially produced, and then how we ended up eventually in recombinant FSH with folitropin alpha, folitropin beta, and today obviously we have folitropin delta, folitropin epsilon, and chorefolitropin. But the key question someone might ask is, why did we have to go recombinant? And the answer again is pretty simple and pretty straightforward. Obviously, because there was a high purity, whereas in the urinary gonadotropins that was not the case. Obviously, we can have endless and reliable source of gonadotrophins, so we're not in need of collecting urine from postmenopausal women. There was a high batch-to-batch consistency. We were able to perform subcutaneous administration, and because they were highly purified, there was no concerns regarding disease transmission. And as recombinant gonadotrophins came into play, so did biosimilars. And I'm pretty sure many of you have heard the word, but it's rather interesting to see how it's properly defined. So as a biosimilar, we define a biological medicinal product that contains a version of the active substance of an already authorized original biological medicinal product, which we usually refer to as the reference medicinal product or the originator. I think it's very important to clarify that biosimilars are not identical molecules and may still differ in strength, in purity, and contain different composition of isoforms or have different glycosylation profiles, which then means that might result in altered clinical efficacy or safety. In many cases, regulatory authorities requires biosimilarity to be proven on the basis of good quality randomized controlled trials. And that's what it's required before these substances can be approved as true biosimilars of an originator product. So we all know that folitropin alpha was one of the first who actually had biosimilars in the market. So it was very important for us to answer a clinical question. We understand that these molecules are similar, but how similar are they truly? So the questions we asked ourselves, probably a couple of years back now, was based on the best available evidence. Are biosimilars of folitropin alpha comparable to the originator in terms of live birth rates? We felt that that was the most clinically significant question because that's what patients are interested in. They're interested in having a baby. So if the biosimilars are true biosimilars, we needed to also be certain that they lead to a similar live birth rate as well. So to answer that question, obviously we could have done another huge study, but in evidence-based medicine, one of the first things you need to do is make sure that you critically appraise the literature and see what evidence you already have before you embark into producing new evidence. So to do that, we constructed a very meticulous systematic review and meta-analysis protocols according to the Prisma guidelines. And this was a protocol that was pre-registered in the International Prospective Register of Systematic Reviews, Prospero, and that was done prior to any quantitative analysis. The literature searches were performed on electronic databases and clinical trial registries, and we searched for randomized controlled trials and conference abstracts describing randomized controlled trials that were comparing biosimilars of folitropin alpha with the originator. The search was conducted and covered the time period until the 31st of October 2020, so fairly recent. We included all studies published in English. Of course, they should have been performed in humans. And we also performed a highly recommended risk of bias assessment using the methodology that Cochrane suggests in their manual. So what were the primary outcome measures? So as a primary outcome measure, we defined live birth rate per randomized patient, which was defined as the number of deliveries with at least one live birth resulting from one aspirated treatment cycle, which included, though, both fresh or frozen transfers, until one delivery with a live birth had occurred or until all embryos had been used. And that's probably more similar to what you might have seen in the literature as cumulative live birth rates. We also registered any multiple deliveries as one delivery for the purpose of this outcome measure, and we included data only from the first stimulation cycles. Secondary outcome measures were clinical pregnancy rate, ongoing pregnancy rate, total dose of gonolotrophins, duration of ovarian stimulation, number of oocytes retrieved, anything you would expect that we would have done or would be of interest when comparing different gonolotrophins. We also looked at cumulative live birth rates. And by cumulative live birth rates, these were and cumulative ongoing pregnancy rates. These referred to pregnancy rates over a number of stimulated cycles, but not all studies provided data for this outcome. This is the Prisma flowchart, and I'm pretty sure you've all have seen this flowchart because it is, it is considered a standard in the reporting of systematic reviews and meta-analysis. And you can see clearly that we started with around 2089 potentially eligible studies. And after perusing their titles, their abstracts, and then their full text, we ended up with 5 studies that could be included in the meta-analysis. Which studies were those? So these are the studies, and you can see also what type of biosimilars each one has evaluated. You can see that the sample size of this study is very widely, and from 110 being the smallest to around 1,100 being the largest. All of these were randomized controlled trials, single-blinded, and again, you can see that all but one had the number of oocytes retrieved as a primary outcome measure, and only one, the largest one, of course, had as a primary outcome measure the clinical pregnancy rates. Some of you might already be asking why so many studies had the number of COCs, the number of cumulative oocyte complexes, as a primary outcome measure. And the answer is actually quite simple, is because these studies have been used by the companies that market them in order to obtain approval from regulatory authorities, which means in order to prove that the biosimilars are non-inferior to the actual originator. And according to the regulatory authorities, this needs to be proven in terms of number of oocytes retrieved or cumulative oocyte complexes. Here you can see the type of protocols that were used, and I think you would find it reassuring that all these studies used what we would consider conventional dosing of FSH, somewhere between 150 and 225. And of course, you can see the other characteristics of the studies in terms of the dose adjustments that were allowed and how many cycles each study eventually had included. So moving straight ahead to what I think is the essence of this presentation is what were our findings. So as we said, the first and probably most important question we asked is whether a biosimilar is equivalent or similar to the originator in terms of live birth rates. And based on the available studies, there were 4 of them, including around 1,900 patients, we saw that the relative risk was 0.83 and was statistically significant, as the confidence interval does not cross 1. And what that meant was that the biosimilars are actually associated with a significantly lower chance of live birth per randomized patient compared to the originator product of folitropin alpha. And interestingly, the same finding was confirmed in ongoing pregnancy rate. And you can see in this scenario, the relative risk is 0.81. So very close to 0.83, which was the effect size of in live birth rates. So very consistent findings between both live birth and for ongoing pregnancy per randomized patients, again favoring the originator of folitropin alpha. I would like also to draw your attention to the heterogeneity of these studies, and you can see that it's 0%. And if you don't really believe the numbers and you would like to see with your own eyes, you can see that all the studies, all 4 studies that provided data, all of them, as you see the forest plot, are to the left, which suggests that they favor the reference product. Interestingly, none of these studies, obviously, produced statistically significant results. And one can only assume that this was due to the fact that they were underpowered. Finally, moving on to clinical pregnancy rates, you can see here, again, the same story repeating. The relative risk is 0.82 in this situation, again, suggesting significantly lower clinical pregnancy rates with biosimilars compared to the originator for the tropin alpha. And the story is also similar here, where you can see that there is homogeneity. The heterogeneity is practically 0. And that is, you can also see the statistic, but with yourselves, you can see how every single study on the forest plot seems to be on the left, which means that favors the reference product. But again, every single study, just because it was not large enough, could not detect this difference on its own. Moving on, cumulative live birth again suggested significantly lower cumulative live birth rates with the biosimilars. Cumulative clinical pregnancy, the same story, and it was only cumulative ongoing pregnancy, although again, the relative risk seems to suggest that the confidence interval is too wide, crosses 1, therefore that particular result is not statistically significant. What about secondary outcome measures? I think OHSS would be one of the things that most of us would be interested in. And you can see that the studies here seem to be highly heterogeneous, but importantly, the relative risk does not seem to suggest that there is any difference between the 2 products compared, the biosimilars and the originator of folitropin alpha, in terms of OHSS occurrence, of course. Moving now to stimulation characteristics. There was no significant difference in the total dose of gonolotrophins between the studies. The number of oocytes retrieved, interestingly, was slightly higher by about 2 oocytes retrieved in the group of the biosimilars compared to the originator. And please focus on that, because I will be discussing a bit more about this later. And the duration of stimulation was indeed a bit lower, but only by 0.2 days in the biosimilars compared to the originator of folitropin alpha. Therefore, if we had to conclude, and our conclusion in that study was that the latest randomized evidence suggests that live birth, ongoing pregnancy, and clinical pregnancy rates are significantly lower with biosimilars of folitropin alpha when compared to the originator. At the same time, it appears that biosimilars of folitropin alpha were associated with shorter duration of stimulation and also led to a higher number of oocytes retrieved. And as I said, keep that last sentence. Why? Because that's something that really started, really made us think, how is that possible? And obviously, there were colleagues that suggested, well, it's not about quantity, it's about quality. And therefore, the oocytes might be more, but they might be of lesser quality. Or some suggested that it might have to do with the endometrium, meaning that they affect differentially on the endometrium. Therefore, despite the fact you have more oocytes, and the damage that actually applies on the endometrium leads to these results. All these were hypotheses, of course, but we kept looking into our data. And then we realized that it's very, very likely that what the authors of the Folitrope study present in their manuscript is incorrect. And why, I will just let you know that the Folitrope study was not the largest one, and the Folitrope study is the 4th one. But you can see, although the first 3 studies seem to be fairly similar in terms of what they suggest for oocyte retrieved, the Folitrope study is way on the right, which means that the results are highly heterogeneous. But what really caused to us, at least, a significant surprise was that it appears that the confidence interval is very, very narrow. And the standard deviation is very, very narrow. So we felt that that's an unrealistically small standard deviation. And therefore, it's very likely that what the authors actually reporting, despite the fact that they say that they report standard deviation, is a standard error of the mean. So we have written obviously to the authors and we're waiting for their response into the journal. But if, for example, we assume that indeed that was the case and we convert the standard or the mean to the standard deviation, then you can see that the mean difference in number of oocytes retrieved is no longer statistically significant. Again, it favors the biostimulus, but this time only by 0.3 oocytes, which is not statistically significant. And what is important, assuming that this is truly what's happening, and as I said, we're waiting to hear from the authors before we can formally issue a corrigendum to our meta-analysis. If you see this chart, the heterogeneity now is 0%. So given the homogeneity and the lack of heterogeneity in almost every other outcome, we feel that this is far more likely to be the right answer. But obviously, this is something that we'll have to explore collaborating with the authors of the Follitrop study. So why the results, though, then might be different, and why, as we said, still biosimilars seem to have a shorter duration of ovarian stimulation, and most importantly, why do we see this striking difference when it comes to live birth rates, ongoing pregnancy rates, and clinical pregnancy rates in favor of the originator? Well, first of all, as we've said, the products are similar; they're not identical, which means there is a great, there is a significant scenario where indeed they differ significantly. So, what do we mean? So we need to look at the FSH isoforms. We know that there are differently naturally occurring isoforms of FSH. We know that each one has, in humans, about 4 glycosylation sites, especially when we're talking about folitropin alpha. And these sites can bind with N-glycans, which can be further charged with sialic acid or sulfate. So when we do have sialic acid binding, this means that these versions of the FSH, these isoforms, are more acidic. And what that means is that they have a longer half-life, but also lower in vitro biological activity. So although in the lab, they seem not to be binding the receptor as well as the ones that are less acidic, because they have a longer half-life, that actually translates into higher in vivo potency. And that has been shown in the study by Mastrangeli et al., published in 2017, where they did exactly that experiment where they compared Benfola, which, as you know, is a biosimilar, with the originator folitropin alpha with Gonal-F, and that they could see very clearly that there was a different profile of glycosylation with a higher proportion of isoforms with tri- and tetrasialization in the Benfola arm. And this actually translated to higher in vivo bioactivity. And to put that in numbers, the average bioactivity of Gonal-F was 97.3%, whereas for Benfola was 105.6%. And that's obviously compared to the nominal values, what we would expect. What about the batch-to-batch coefficient of variation? As we all know, it's very important that batches are very similar, so our doses is not changing meaningfully. Again, compared to the nominal values, the Gonal-F was more consistent compared to Benfola, which showed greater variation. So these are very interesting findings. And of course, the RCTs represent the pinnacle of the evidence-based pyramid. But as we very well know, many times evidence randomized controlled trials might not say the complete truth, or the results might not translate to what we see in real world. And that's because many times people suggest that the randomized controlled trials are too strict. They include ideal patients, whereas we're treating real patients that have other issues, for example, around the weight, diabetes, other comorbidities that might be influencing the balance between the two proposed gonolotrophins in this case. So I think it was very important for us to also have a look at the real world evidence, and that's what I would like to review now. This is a very big study, which was a non-interventional study based on the French National Health System database. And that's essentially a big database, and it involved a great deal of data linkage. So it's a big data study, and it's an exhaustive medical administrative database with cover of about 99% of the French population, around 68 million of insured individuals in France. And this was a study where they tried to identify all ART cycles between 2013 and the end of 2017. And they included eventually 135,000 women having performed 214,000 cycles. So really big data. So the question that they wanted to ask is, how effective is ART in terms of cumulative live birth rate in France, depending on the gonadotrophin used? And I won't keep the results from you much longer. As you can see here, very, very interesting, this paper. I would highly recommend you go and read it. When they compared the reference product of folitropin alpha with the biosimilars, they could see that there was a 16% lower relative chance of live birth with biosimilars compared to the originator product, to Gonolef. And this is surprisingly similar to what our meta-analysis suggested through the randomized controlled trials. Again, very reassuringly, the OHSS rates were almost identical between the two groups, showing clearly that there is no difference between the two. And of course, there were limitations to this study, which I think is important to be discussed. This study included only cycles with egg pickup. Therefore, if someone had canceled the cycle, and if one of the two biosimilars had a higher chance of cycle cancellation, for example, due to the risk of OHSS or due to a very poor ovarian response, then that cycle, unfortunately, has not been included in this database. There were no data regarding ovarian reserve, because some people consider that unless you have data regarding ovarian reserve, you cannot really know whether the populations are comparable, and that's a fair criticism. And of course, the biosimilars, the recombinant folitropin alpha biosimilars, were only available since 2015. So essentially, we had only 3 years of data, 2015, 2016, and 2017. And therefore, I think the results should be interpreted with caution. Another important question, and this is, I think, the last portion of my presentation, is why we use biosimilars. Well, most of us, or whenever we use biosimilars, the common argument is because they're most cost effective. So taking cost into account from a health policy perspective, or even from a patient perspective, it's always very, very reasonable. But we should not just be looking, as we've said, on whether they are of a lower cost, but whether eventually they are cost effective. And by that, we mean whether every live birth that we will get has costed the same, or ideally lower amount of money to be achieved. Again, let's look at the data. This is a study that we published with Dr. Greenberg being the first author in France. And as you can see, two different scenarios were examined here, with OHSS and without OHSS. And interestingly, in both cases, it became very evident that the reference product, the originator, was the most cost-effective option compared to biosimilars, and that was irrespective of the incidence of OHSS. Another study from Germany, and as you can see here, with dark blue is the originator, with light blue is the biosimilars, and in every scenario, the cost per live birth, and depending on the different biosimilars, was lower with the originator. And these authors also concluded that the originator of folitropin alpha seems to be the most cost-effective option when compared with the biosimilars. Finally, this is a study we recently published with Dr. Svarch, and it includes data from the Spanish system. And as you can see again, the incremental cost-effectiveness ratio is 7,208 euros, which essentially once again means that the originator is the cost-effective option compared to the biosimilars. Obviously, one thing I need to note is that all these three studies have been performed in Europe. Therefore, these results, although they seem fairly consistent, would need also at some point to be replicated in other settings, because each country might have a different type of reimbursement or a different cost for the biosimilars and the originators of folitropin alpha. So, reaching the end of my presentation and thanking you all for your patience, the conclusion, I think, and I hope this has become evident, that the meta-analysis that we conducted of published RCTs comparing the biosimilars of folitropin alpha with the originator suggests clearly that we have lower live birth rates over the first or multiple stimulation cycles in women using biosimilars when compared with the originator. These findings, reassuringly, seem to be confirmed using real-world evidence. Biosimilars can vary from the originator both in terms of biopotency and in terms of batch-to-batch consistency. In 3 different cost-effectiveness studies, all of them in the European continent, the originator for folitropin alpha was more cost-effective compared to the biosimilars. Obviously, we're not done. These are very, very intriguing findings, and I'm very happy to discuss the implications of these with you. But I think we need further studies to confirm or rebut these findings. And for me, the most important reason to conduct further studies is to identify the pathophysiological reasons for the observed differences. Because if we do, then potentially there might be light at the end of the tunnel, and we might be able to manufacture biosimilars that will also be similar, not just in terms of number of oocytes retrieved, but also in terms of live birth rates. I would like to thank you all for your attention. It has been a pleasure being with you, and I'm looking forward to a very, very intriguing discussion with all of you. Thank you.
Thank you, Dr. Christos. It was a wonderful presentation and an eye-opening presentation also. I think we carry forward now, as Dr. Someshwar suggested, that I will share just our Indian experience about the same. So this is just a poster presentation which was done at the International Fertility Vision, that is IFS in India, in December last year, where we presented this poster of clinical outcomes in patients receiving folitropin alpha biosimilar to originator, that is the Gonal-F, in real-world clinical practice. So it was presented by Dr. Lena Patel to compare the live birth rate in assisted reproduction under patients undergoing Gonal-F versus biosimilar. So it was a retrospective analysis observation study from 2016 to 2020 in a tertiary assisted conception unit, that is our Akanksha Hospital and Research Institute. And the study population comprised of infertile women undergoing ART who were administered biosimilar or Gonal-F, a total of 174 and 190 women who were administered Gonal-F and biosimilar respectively were included in the analysis. So it is a retrospective cohort of 364 women, either undergoing fresh or frozen transfer at blastocyst stage or at cleavage stage embryos. And the main outcome we measured were the clinical pregnancy rate, the miscarriage rate, the healthy baby, that is the term live birth with appropriate weight and no congenital anomaly. Any preterm birth was also recorded, and statistical analysis was done by chi-square. So here we found, I'll just go to the main poster and we'll finish here only. So the number of embryos, the 2 cohorts over here, are similar regarding the demographic, that is the age of the patient, on an average 32.5 versus 29.7, that is the originator versus biosimilar. AMH was comparable, 4.2 versus 5.1. The gonadotrophin dosage here we observed was slightly higher in the originator group versus the biosimilar, that is 2870 to 2600, but not significant. Yes, but we found the number of oocytes in both the groups comparable, 13.4 versus 14.5. Significant difference was observed in the number of embryos, that is both at the cleavage stage as well as the blastocyst stage. So on day 6, we had 4.3 blastocysts of Gonal-F versus 3.46 in the biosimilar group. The clinical pregnancy rate in the Gonal-F group was 56% versus 40% in the biosimilar. The full-term live birth rate was 39% versus 27%. Higher percentage of women had good quality embryos, both the cleavage and the blastocyst in the Gonal-F. It was significant, 83 versus 69%. Though the clinical miscarriage rate was comparable in both, 7.6%. Further, we also thought that as we are always trying to use the best gonadotrophin and the recombinant in the advanced age, low AMH, let us see the impact of using this versus the biosimilar in the age group of less than 35 years. So we had group A, which comprised of patients less than 35 years, and group B more than 35. And we were surprised to see that even in group A, which is less than 35, where we think that any gonadotrophin, she's young, she has good oocyte, everything is fine. Whatever you use, she's going to give good eggs and good embryos. We found that with the originator, the number of blastocysts was higher. There's 4.3 compared to 3.1 in the biosimilar. Even the cleavage stage embryo transfer were similar in both, whether it was blastocyst or cleavage stage. The good quality embryos in a younger patient was 82% with the originator compared to 68% in the biosimilar. So in a younger age group also, the quality of the gonadotrophin that you use matters. The clinical pregnancy rate was 55% in the originator versus 40% in the biosimilar. And live birth rate, you can see the difference in a young patient was 40%, 41% in the Gonal-F group compared to the biosimilar, where it was just 26%. So this current study, which was a retrospective analysis though, definitely demonstrated the effectiveness of clinical pregnancy live birth rate when we compared the originator polytropin alpha over its biosimilar. So that is very important. And even the similar number of oocytes, pregnancy rate and live birth rate was higher in Gonal-F in the younger group also. So the number of oocyte does not matter. It is the number of good quality embryos and the ultimate outcome of live birth rate and a healthy baby which matters, and where we concluded that the originator was better than the biosimilar, and then there was a significant difference in the outcome between the two. So with this, I now leave this discussion open for everyone. I'll stop sharing the screen, and I would want the panelists, we have got all esteemed learned panelists over here who can put on their queries over here to us, both of us, mainly Dr. Christos. So Dr. Christos, if I were to ask you that what is it that is most important in the originator versus the biosimilar, if you were to think logically that why this is giving a better outcome than the biosimilar, what point do you think is important?
Thank you. Thank you. I think that is the million-dollar question. And I do think that one of the obvious answers is the embryo quality might differ, just because the oocyte quality might be different. And in the context of the randomized controlled trials, Dr. Patel, we did not have any evidence to support that. But I'm very happy to see that your study seems to be pointing to that direction, and it obviously raises the possibility that this indeed would be the case. And the reason why I think it's predominantly the embryo quality is because the difference seemed to be present both in after the fresh transfer, but also after frozen embryo transfers. And to me, that's a very, very clear sign that it's probably not the endometrium which is affected, but it's the actual embryo that is affected.
I'll just ask one question because I'm going to get a disconnect because of the power failure. So my question is that most of the studies have shown that biosimilar and originator have a similar COC retrieval, and the difference was in the live birth rate. So I would like to ask, what was the support analysis patients in that study you did, which compared severe male factor issues in comparing originator versus the biostimulars, and that is where the egg quality would make an impact.
Thank you, Dr. Jadva. I'm not sure whether, because the line was not good. Can you repeat the question, the actual question?
If we compare the clinical outcomes in male factor infertility, comparing biosimilar versus Gonal-F stimulations, what was the difference over there?
So the RCT, thank you for the question. So the question is, if you compare the the two products, the biosimilars and the originator for the tropin alpha, in cases of severe male factor infertility, what are the findings? And the answer is we don't know. And the main reason being that there was no specific stratification in terms of severe male factor infertility. Therefore, from the randomized controlled trials, we don't have this data. But I would like to ask you, why are you interested in this comparison? What do you try to tease out by limiting your comparison in this specific subgroup?
Because when we are speaking about a male factor infertility, a sperm factor is responsible for the blastocyst conversion rate, right?
Mm-hmm.
And if you're not comparing blastocyst conversion in specifically male factor, then if you have a male factor, you know that the cytoplasm of the egg is responsible for overcoming the smaller issues in the sperm factor, leading to a better quality embryo. So if you are speaking that originator can produce better quality eggs, numbers are similar, then better quality eggs improving the blastocyst conversion could be the answer we are searching for.
Thank you. That's it. That is an interesting option. In the context of randomized controlled trials, even the ones that have included patients with severe male factor infertility, because these are randomized controlled trials, that specific category of patients has randomly been distributed and equally been distributed between the two different groups. And therefore, I don't think that it would have confounded or skewed the results in any way. But, you might be onto something there. It might be interesting, as you said, to look specifically into certain subgroups of women in order to identify whether it's more the egg or not. But because the men are not essentially exposed to the biosimilars, regardless of what the sperm is, the egg will be the one driving the quality of the embryo. And I do understand that many of us have been taught that blastocyst or the embryonic genome is activated after day 3. Therefore, if there is an effect of sperm, we'll see it after day 3. But still, if you have poor quality eggs, even if you have perfect sperm, blastocyst, will not do very well. And we see that particularly in older women, where either we never reach blastocysts, or we have blastocysts that are relatively good looking, but still do not give us pregnancies.
Agreed. And if we have a good quality oocyte, I think it will compensate for the subfertility of that sperm which is over there. So, and in a random trial, we'll have similar numbers almost in both the groups, like we compared the age. So most of the time now the infertility indication is advanced age or it is a severe male factor. So it could be redistributed equally in the both. So we never analyzed that in our poster too.
Yeah, I agree.
So do we have any other question from the panelists?
Good afternoon. I am Dr. Pandit speaking, and I must comment Dr. Christos for a wonderful presentation. I wanted to know, there was a question, there was a concern about cost effectiveness. And we know biosimilars and the originator, that is the recombinant variety, are available in this country. Is it possible that the companies who are making or who are actually having the originals, they can also produce the same thing in this country or other countries where it's being used?
So I'm not sure whether the question is whether companies that produce the originator can produce a biosimilar. Is that the question?
No, not the biosimilar.
No.
The original molecule can be produced in the countries where it is being used. Like, I'll give an example. That will even cut out the cost effectiveness, and it can be more approachable for the people to use it.
Thank you.
Example being in India, we have biosimilars here. And if the company is making the original product, can also start making it here. What are the pros and cons?
Thank you. So obviously, and the first thing I would like just to clarify on the basis of making sure that the message is clear is that although there was a theoretical concern about the cost effectiveness of the originator versus the biosimilars, the studies that have been published, all of them have shown that the originator, which is like the reference product, Gonolotrophins, has in every single case been more cost effective compared to the biosimilars. And the reason behind that is, if you accept, yes, the biosimilars can be cheaper, but if they are not doing their job as well as they should, and therefore they produce fewer live birth rates. Many of your patients will need more cycles, and therefore, adding up the cycles, it means that a single live birth will have costed more money to them. That is just to ensure that this is, so although the biosimilars per unit are cheaper, when you actually see how much money a couple has paid to end up with a baby, our analysis from the 3 European countries shows that when they're using biosimilars, they're actually paying more because most of them have to do more cycles to get there. Whereas when you're using or the originator, they pay less. Coming now to, it's a very interesting question, the second question you asked, and obviously it's not a question I can answer directly. It's probably a matter of the companies that have the commercial rights and the development of the originator products. And it's not an easy exercise to all of a sudden transfer a huge, production line from one country to the other. There are many things, not just the investment, the initial investment, but also things that have to do with IP and other commercial rights. So I imagine it is something that many pharmaceutical companies, and particularly the ones that might have considered, but they eventually realized that it would not actually be to their benefit, and potentially it might have ended up with a more expensive product just because they would have a huge investment that we would need to cover over a period of time. So I think that might be a reasonable explanation, but obviously I'm not, I don't work for these companies. I don't know their financial strategies, and therefore it's just a hypothesis.
Thank you very much.
So we always feel in India that cost is a constraint. And we give a package to the patient where accommodating the recombinant becomes difficult. So whenever a patient walks in our setup and we are suggesting IVF, the first we'll see the affordability that the patient can have. And based on that, we select the gonadotrophins. I'm sure my panelists will agree over here. And this is what I was doing. But at the end of this retrospective analysis, it was an eye-opener that even in younger patients, when we are getting better result with the originator, that is the Gonal-F, it is very imperative that we give the best in the first cycle to the patient, even if it is little marginally costlier, because the patient comes to you for the result. And if we tell them that, look, first time we used biosimilar, we didn't get a result. This time, what different will you do? I will use a recombinant and I will see that we get better oocytes. The patient will immediately argue, why didn't you do the first time? I would have agreed to pay a little more. So Dr. Subendu, in our scenario also, it's time now we look at it from the quality rather than the economics.
Absolutely, I agree with you, ma'am. Absolutely. We actually had a problem when we had to switch over from Gonal-F to a biosimilar, and being in a government institution, we had to follow the diktat. So I just wanted to know your results and your things. Thank you.
I think, and just echoing what my co-panelist has said, sometimes products that are cheap are equally good, but many times cheap products are cheaper for a reason. And especially when it comes to the production of a live birth, I think that the patients need at least to know the results of the most current evidence. And you can very clearly discuss that this is what the latest data suggests. And if they still want to go with the cheaper option, at least I think you have done your job and you have informed them well. And I would certainly like to, use the product that works best, even if that meant to pay a small premium. So I can see, Dr. Patel, that we have one question in the chat by Dr. Palak Gawari. And they say that there is stagnation in follicular growth while using Gonal-F by day 8, day 9. How to overcome this? Adding LH or increasing dose or adding HMG? If you don't mind, I would like to start by answering. First of all, I don't think that it's a universal phenomenon. It's actually quite rare to have this type of stagnation in follicular growth. But when you do, yes, I do agree with you. Some form LH needs to be added, especially when this stagnation is also accompanied by a plateauing of the levels of estrogen. Then by adding LH like Luveris or even HMG, either could do the work in my view. You most of the times can overcome this. especially when you don't have any reason to suggest that you're underdosing the patients. If you were underdosing the patients, probably you would have not seen the growth that of the follicles that you would have expected. If you're thinking that the growth has been adequate and the recruitment of the follicles has been adequate, and then especially in the mid to late follicular phase, you see a stagnation, as you say, then adding recombinant LH or adding HMC, any type of LH activity would be beneficial in my view. And there is evidence about this. Like Maria Pia Ferraretti, I think, was the first one in 2004 that actually published a relevant study. I'm pretty sure it was in fertility and sterility, and showed how this mechanism could work.
Dr. Christos, in continuation with that, is there something like you do an FSH test on that day, and if you find that the FSH is less than 20, you continue increasing the dose of FSH, or if it is more than 20, then you add LH? Is there something like that?
There is people, and I know Human Fatemi, my good friend, has now been publishing on this. It's not something I have been routinely using. I always, obviously, whenever you see these types of instances, you always make sure you troubleshoot with the basic things. So I have my nurses ensure that the patient is taking the injection correctly, that the batch is a good batch and has not expired, that has been properly maintained. Because as you probably know, there are settings where if the product is not kept is not maintained using the manufacturer's proposed conditions, then it might actually affect its efficacy. So that's something we should also be taking into account. And yes, we do measure FSH, and I very rarely, I don't recall ever having it seen less than 15. My cutoff is 15. If the FSH is more than 15, I feel that they get enough FSH in their system. You mentioned 20. I use usually 15.
Okay, fine. Thank you. There is a question from Dr. Shivali Tripathi. Does the RCT discussed have any difference between self and donor oocytes?
No, that would be, thank you for the question. That's a very interesting question, and would be a very interesting model to discuss, because that would allow us even better to see whether there is any involvement of the endometrium, as women that receive donor eggs have obviously had no exposure to recombinant, to the biosimilar or the originator. But unfortunately, all the studies, the RCTs that have been published to date, have been performed in autologous cycles in women using their own oocytes.
Dr. Shivali, in our retrospective analysis, it was all self-eggs. Donor cycles were not included.
So that might be an interesting, comparison to be made. If some of you are using biosimilars and you are having a good donor program, maybe it would be interesting to see within the donors and within the recipient and within, obviously, also the autologous cycles, whether there are differences between biosimilars and the originator. And, that might be a very interesting study and an interesting publication.
Or if the donor is allowed to donate more than once, the first time you use the biosimilar, second time the originator. In India now, according to the new ART guideline, one donor once. But in countries where they're allowed to use more, donate more, we can do this analysis in the same way.
And that exactly, thank you, Dr. Patel. Beautiful model, especially when you control for the donor factor. Beautiful model if you have enough sample size and if you have done this type of, if you have enough sample size, that would also be very, very informative.
So one more question. Thank you, Dr. Uma. This is now Gonal-F has come in combination with LH. So I think she's talking about parvovirus.
My question is, now Gonal-F has come with LH combination of 2:1 ratio. How you will decide which patient need only Gonal-F or which patient need the combination?
Thank you. That's a very interesting.
The company Pfizer, which promotes Menopure, they said that you should use Menopure. Now people, how we will decide whether we should use pure FSH combination or pure FSH with LH in 2:1 ratio?
Thank you. I think it's very clear from the literature that recombinant FSH alone should be the first line treatment for most patients. And probably for all patients, unless you have a hypo patient, of course, and then you do need LH activity. And of course, you need to give either Percoveris or, Menopure. But in patients that do not appear to be hypo, then obviously you can have a look at the results of the monotherapy. And if you feel that for some reason you observe the phenomena we just discussed, or you have a very poor oocyte growth or very poor oocyte quality, then you could potentially discuss during the next cycle, change things and to try something different, and adding LH activity either in the form of HMG or in the form of pergoveris. I think it is something worth trying. There is some evidence which is not of great quality, and I need to be perfectly clear on that, that potentially adding LH from an early stage might be beneficial. And but at the same time, we have not yet properly identified which group of patients that is. Some people hypothesize that might be women of advanced reproductive age. Some people hypothesize that might be extreme poor responders, but we don't really have the targeted randomized evidence to say with confidence that, yeah, this is the patient that definitely should have pergoveris or should definitely have Menopure. So I think this is still something that will probably remain within, the spectrum and within your clinical reasoning. But what I do for most of my patients, as I said, I start usually with recombinant FSH alone, and only when I see that there is a need for LH activity, then I will add, or I will start from the beginning with the two products that you just mentioned.
Does it have any relation with the AMH?
No, I personally do not think so. And I don't think so also that it has a great relation with how high are the LH levels. Some of my colleagues clearly... Yes, or AMH. That's why I'm saying, because as you know, in many cases where we have very high AMH, we might also have a very high LH drive. So I don't think that's necessary. I also am not a huge proponent or a huge supporter of thinking that you should always have some type of low-key LH activity. I know that some of the colleagues measure the LH activity and add LH. I think it makes physiological sense, but I yet have not seen the randomized evidence to clearly showcase that. So I'm not suggesting that there is no association, because I feel that the jury is still out. But I would like to see the next randomized control trial where it will be taking patients that have a low LH, endogenous LH, or a low measurable LH during the follicular phase. And in half of them will add recombinant LH or Menopure, and in other half of them will add placebo or nothing, and then compare the results. I think that would be a great answer to the question you just posed. But thank you, very interesting question.
So we have Dr. Vinod Kumar. Why the number of follicles are less in the Gonal-F?
Thank you. So again, probably the question in this case might have to do with, as I said, the acidity, or the fact that the Gonal-F with the different biosimilars, the Gonal-F seems to be more basic as a product, which means it does have a higher in vitro biopotency, but because it has a shorter half-life, it has a much a lower in vivo biopotency, meaning you have more stable doses, but these doses do not reach the levels that the biosimilars reach. And interestingly, that appears to be the case with another recombinant folitropin delta, who seems also to be significantly more acidic, and therefore the clearance in the body is less quick, and that means that it ends up stimulating the ovaries more potently. And I know that might get some of you excited. You might say, oh, that's great, because I can give now 200 units to my patient, and instead of getting 11 eggs, I'll get 12 eggs. But as I said, particularly in lieu of the results of our meta-analysis, I would be quite skeptical about following such an approach. As Dr. Patel said, I think we need to focus more on the embryo quality, and obviously more importantly in live birth rates.
Exactly. Less is more. What is they say now? There is Dr. Roshini. She is asking, hello, sir. FSH more than 50 cutoff after how many days of giving recombinant FSH?
Yeah, at least five. I know that as soon as, and it's not just that, it's also when you measure. we know that when you give, we know, for example, that when you give any type of FSH or HMG, usually in about 8 to 10 hours, it will maximize its concentration in the serum because that's the pharmacokinetics. So if, for example, you measure the results of you want to ascertain the FSH levels just before you give the FSH injection, meaning that the prior FSH injection was 24 hours ago, then in those cases, you probably you're gonna find the recombinant FSH, the FSH levels at their lowest. The other thing that we know from the first pharmacokinetic studies of Lekotonek and colleagues back in 1994 and 1995 is that any change in the dose of the FSH takes about 4 to 5 days to actually show up in the concentration in the serum. And that's why I tend to measure, all my patients receive their FSH in the evening, and I measure their blood tests in the morning, and I measure FSH when they've had at least 4 to 5 doses of FSH, because by then they will have reached a steady state. As you've all have seen the charts, when we give FSH, it goes up, and then if we give it starts going down, but then we give another dose, it goes a bit more up, and it reaches steady state after 4 to 5 days.
Great. Dr. Palak is asking, does recombinant and biosimilar thing apply to HCG also? HCG injection also, is there a difference between recombinant and biosimilar?
I do not know, and obviously I don't think a relevant meta-analysis has been done. I do think following the publication of this meta-analysis, many people will start looking back at the comparison between the reference products and biosimilars, as it is clear that being just similar might not be good enough. But to the best of my knowledge, there hasn't been such a meta-analysis. Therefore, it is an open question, and I would encourage whoever asked that question, they can look in the literature and they can produce a meta-analysis and enlighten us all.
Okay, thank you. Dr. Shivali has asked, in some of our patients, we have seen persistent slow response to Gonal-F. Does anybody have similar experience? It doesn't pick up even after adding HMG and increasing the dose.
Interesting. It would be interesting if Dr. Shivali gave us some more information about, I imagine they have a pretty good understanding, or at least they have their suspicion on whether there is a specific type of patients that, this might be happening. I would say that whenever I see any type of slow response, particularly in terms of estradiol production, I will tend to add some LH, especially when they're very, very suppressed. The only cases where I can see slightly attenuated response to any gonadotrophin, and I don't think that's exclusive to Gonal-F, is when these women have been, severely suppressed for quite a long time, either because they've been taking the pill for months and months or years, or because they've been doing ultra-long GnRH agonist protocols, either for reasons of convenience or because in some cases they have endometriosis and some of their clinicians want to put them in the very ultra-long down-regulation protocol. That's my personal view and my personal experience.
Or the polymorphism thing that's coming up.
Yeah.
So there's a question from Dr. Roshni. Hello, sir. In some patients, estradiol levels don't correlate with the number of follicles on the day of trigger. What could be the reason?
I can tell you straight away. It's first of all, it's not just about the number of follicles, but it's the size of follicles. And the second most important thing is the LH levels that they have in their circulation. If the LH levels are undetectable and you are not adding any LH, the estradiol levels are going to be very low. But that does not mean, again, that these are all compromised oocytes. But whenever you're very anxious about this, I would just ask you to add some LH activity, either in the form of recombinant LH or HMG, and you will see the next morning that their endogenous estradiol levels have just skyrocketed. And many, many times I have junior colleagues calling me in panic because they said, oh, the estradiol levels were about 6,000 to 7,000 picomoles per liter. And we thought over the weekend to add some LH, and now they are 30,000. and I'm telling them, don't worry about it. It is what it is. It was just the fact that because previously your LH was less than 1.4, you could not really see it. The LH levels, or were always in a way meant to be, the estradiol levels were meant to be high. It's just that particularly in follicles over 14 millimeters in mean diameter, the most potent steroidogenic stimuli is LH activity, because those follicles express LH receptors that do the job that FSH receptors do at earlier stages.
Will the antagonists play a role in reducing it drastically, the estradiol levels?
Sorry, can you repeat the question,
The
Dr. Patel?
antagonist injection in some patients can reduce the estradiol drastically.
Which injections? Which injections? Sorry.
The antagonist.
Yeah, absolutely. Absolutely. And it's exactly the same mechanism. They crash the LH levels, and that's how they also induce luteolysis. And we give the antagonist levels sometimes in women that, we think they're at high risk for HSS, even after OPU. That's a strategy that has been suggested by some. And I think Dr. Lena's group from Greece has published a couple of studies using that approach. And I think it's an interesting approach, and it's one of the proposed mechanisms.
So the message we take over here is that if you are seeing good number of follicles, the estradiol turns out to be low, you can either test LH and add LH, or otherwise straight away add LH, and you will see the estradiol rising, giving good follicles. Yep. So good message for everyone. Dr. Rashmi is asking, is there a minimum effective dose of Gonal-F and a ceiling dose?
Thank you. Again, I was having I actually yesterday, 2 days ago, I had a presentation in a postgraduate program in a Greek university online, obviously. And one of the questions, and it was about strategies of ovarian stimulation. And there were many, many excellent colleagues there. And that was one of the questions that we tried to resolve. And one of the things I told them is that the most important thing, probably the most important decision that the clinician has to make in terms of ovarian stimulation is just defining the starting dose. The starting dose can give you either an appropriate ovarian response, an under response, or many, many times a hyper response. It's very difficult to correct mistakes, not impossible, but it's much more difficult to correct mistakes that you do when you give a very high starting dose. So I think in terms of the evidence that have been published, and you can see Sarah Lenson has published a very nice systematic review and meta-analysis in Cochrane. It depends on the type of patient you have. If we're talking about patients that have a normal body weight, because that's also something that needs to be considered, then I would say the normal dose would be somewhere between 150 and 225. The available evidence suggests that for the vast majority of women, giving more than 300 units per day probably makes no sense. For very lean women and with polycystic ovaries, the dose can go all the way down to 75 or 100, depending on how many eggs you want to do and what are your triggering criteria. I would invite you all, because I think it's very relevant, for those of you who are attending either virtually or in person ESHRE this year, I've been invited and I'll be giving a talk in the pre-congress course by the SIG of Reproductive Endocrinology and Infertility, just about the goals of ovarian stimulation and whether we should be changing our triggering criteria based on the different signals and the different strategies. And there I have, I think, a pretty comprehensive review of all the literature, so some of you might find it interesting. So to come back to the original question, I would say the lowest probably in my books, and especially here in Australia, would be 100. The highest for women that probably are less than 70 kilos would be 300. For women that are more than 70 kilos, or they're like 90 or 100, I would say you can go up to 450. But that's all, that's where my absolute ceiling. But that's not necessarily based on studies. That's based more on my clinical experience.
So I would like to add two things now over here. One is the ethnicity, how an Australian lady would respond, how an Indian scenario, what they will respond. And second is the potency of the recombinant FSH available there, available in US and available in India, that the Mirinda or the company can answer. So
absolutely. No, Dr. Patel, I agree with you 100%. As you said, there are polymorphisms. We've done studies where we've administered certain types of gonolotrophins in Asian women that reside in Sydney compared with Asian women that reside in Hong Kong, and we found that they respond very, very similarly. And then when we compared them with non-Asian women in Sydney, we saw that the non-Asian women were actually responding much better, which means that, for example, in the Asian population, there is a specific polymorphism which creates this type of pharmacogenomic landscape that allows them not to respond, or at least leads them not to respond the same way like all other women. So I completely agree with you. Taking into account the type of population and obviously the biopotency of the molecule you use is also very, very important.
Absolutely, thank you. So we have Dr. Vinod Kumar, Dr. Nikita. She's asking if FSH level is less than 10, will you add LH? That's day 2 FSH, I guess, less than 10.
No, I would not. I would probably increase the level of FSH because, as I said, if after starting administration of FSH 5 days, our FSH is less than 10, the first thing I would again go back and look at is she taking the correct medication the right way, and making sure that the medication she's taking has been properly maintained. Sometimes I might even change the batch. But no, I don't personally see the benefit at that point in time of adding LH because she does not seem to be getting enough FSH stimulus. The problem with adding LH too soon, any type of LH, is that you can limit the number of eggs you get. And I know we've just said that it's not just about the quality, the quantity is about the quality. But if you do it too prematurely, you might limit the number so significantly that the overall outcome might be not in your favor, not in the patient's favor.
So there's one more question by Dr. Vinod Kumar. Does FSH given at different timing, say early morning versus late evening, has any significant difference in action?
Interesting question. I wouldn't think so. And I wouldn't think so. Why? Because FSH do not seem to be affected the endogenous as much by the circadian rhythm. And we just, for reasons of convenience and for reasons of being able, when we do our blood test, because in Australia, most patients do their blood test somewhere between 7 and 9 a.m. We want to make sure that we are having very standardized measurements. The general plan is have FSH in the evening and have your antagonist when we're using the antagonist cycles in the morning. But I don't think it would make any difference. I don't think it would make any difference. At least that is, my understanding.
So you never give both the injections at the same time. Morning you give.
Sometimes, no, that is our preference. But sometimes patients prefer, or because they're working in a setting that they cannot take time to do an injection, or because they're working night shifts. Sometimes some patients will say, would it be okay if I take both injections at the same time? And usually I prefer being about an hour apart. But yeah, some patients will actually take both in the evening.
So normally you prefer hour apart or morning antagonist, evening and you see a difference in the...
No, it's just, Dr. Patel, I don't think it's a difference. It's a matter of us being able to look at their blood tests and understand better what's been happening, trying to keep it as standardized as possible. And that probably goes back to when I was doing many, many clinical studies, where in order to make sure that we interpret the data appropriately, we wanted all the patients to be taking their medication at the right time. Otherwise, the bloods would throw us off. So that is a habit, unfortunately, that has stayed with me. And even now, where I'm still doing studies, but most of my patients are not part of studies. So I do feel more comfortable knowing the rough time where they had either their FSH or their antagonist for the reasons I outlined. Just knowing the pharmacokinetics make you at least can help you understand better of what's happening in that woman's body.
It's not a necessity, but because here the patients, they don't administer injections on their own. They normally come to a clinic or to a nurse to the injections, and they would not want to travel twice. So they take all the injections at the same time. I think.
And yeah, absolutely. And I don't want to give the message to anyone that it's better and it improves the outcomes. I have no such evidence. And I do think that it's very likely when women take it at the same time, they do equally well. It's just that in my clinic, in my practice, that is the preference. But as I said, even within my patients, many will say, oh, can I take both in the evening? And then we just give them the relevant instructions.
What is your experience with coasting? When you are giving the recombinant FSH, you see the follicles growing well in a good number. Would you do an FSH level, stop the injections for 1 or 2 days, reduce the dosage, or continue the same way?
I have very, very limited experience, Dr. Patel. I mean, my experience probably dates back more than a decade. Ever since we had the introduction of the GnRH agonist, and because in my clinic, probably 90% of my cycles are antagonist cycles, I rarely have to do coasting. I think that coasting is something that you can do, again, in my view, only if you're desperate. And I do think it can have a negative effect on the oocytes, particularly when you're doing it blindly. Because in the old days, we didn't use, like, we would do coasting predominantly, at least in my clinic, to avoid OHSS. And we rarely would measure FSH. We would measure estradiol, but we would rarely measure endogenous FSH. As I said, I'm very fascinated by recent data that suggests that you can do this type of individualization on the basis of the endogenous or the FSH levels. Again, it's an interesting theory and there are some supportive evidence. I don't think it's widely accepted yet. And I'm looking forward to seeing more data. And if I see that it's actually something beneficial, I would be, happy to give it a go.
Yeah, Dr. Human Fatemi is doing it a lot, and that's what I got the information from. Any other
Dr. Patel, because Human is a very good friend of mine, and we were actually together, in a virtual meeting again 4 days ago. The interesting thing is the reason why he predominantly started doing that is to reduce the incidence of elevated progesterone, of the progesterone not going up. He wanted to make sure he doesn't give enough. And that is because when I asked him, why would you think of doing that? And he said, oh, I'm just trying to reduce the incidence of elevated progesterone. And the main reason is because in their clinic, doing a fresh transfer is very, very important.
Agree. And one more question, that in Indian scenario, the IVF specialists are in favor of adding a little dose of LH at least towards the end, from day 8, 9, 10. What is your experience? You just continue on FSH, or as a routine, you add LH for the last 1 or 2 days in each patient?
No, I do not do it routinely. I would say probably 50% of my patients will not have LH as an addition. But yes, there is a number of cases, particularly like the ones that we've discussed, where I would be adding recombinant LH, particularly in the late follicular phase. But as I said, I do not do it routinely because, and I do not do it very early because I do know that adding LH will certainly give a big kick, a big push to the bigger follicles, but it will not help so much the smaller follicles. So it's also sometimes, Dr. Patel, an issue of how homogeneous the cohort is, the follicular cohort. So that's something also I take into account. So I do use it, but not routinely. So recently I was interacting with Dr. Urmila Divekar, who is in the Chicago, and they are analyzing the dose of FSH based on the enterofollicle counts they're not considering. So it's a very nice app that they've come out with, and where they feel that after 5 day or 6 day, definitely all the patients will need a reduced amount of FSH rather than the same FSH. And even then, the follicles will still keep growing and you get the maximum number of follicles. In the IVF worldwide, there is a talk today or tomorrow. Tomorrow she's talking on that. So that is also an interesting app that we can think of reducing the FSH dose. And adding LH, I think it's the Indian scenario. Most of the foreign speakers where I've heard, they don't want to add LH routinely. There's one more question from Dr. Vinod Kumar. Are there studies with Gonal-F exclusively on poor ovarian reserve and its results? If we are referring to the topic of the present talk, which is the biosimilars, no. The studies that have been published, the randomized control studies that have been published, have all been performed in normal responding patients. If we're talking about generally studies on poor ovarian response using Gonal-F, yes, there are hundreds, but most of those studies, or at least the randomized control studies that I'm aware of, are actually evaluating whether adding recombinant LH can make a difference or not. And as I said, the overall concept before the ASPART trial was that yes, adding recombinant LH can increase the number of oocytes retrieved and the clinical pregnancy rate. And that was based on a meta-analysis we did and published in 2014 with Professor Laheret as the first author. But then that meta-analysis essentially was the basis for the ASPIRE trial. And in the ASPIRE trial, they took poor responders according to the Bologna criteria, and they evaluated whether adding recombinant LH would have a beneficial impact. And that was not unfortunately proven. They couldn't find a difference in pregnancy rates. In a sub-analysis, they did find that for a specific portion of the poor responders, that was beneficial. But what we're currently lacking, and hopefully we will have the evidence soon, is essentially confirmation of these findings in an independent randomized controlled trial. Because I'm pretty sure you're all aware, whenever we do many subgroup analyses, we might find something as being statistically significant just by chance. So we always take these type of analysis as hypothesis generating rather than as hypothesis validating. And that's why I'm saying we're still probably waiting for the new studies that will confirm those types of sub-analysis.
There is this paper where they've said, I think the study that you mentioned, from 35 to 39 years of age, it's good to add LH. Above 40, it's just pure FSH, which can give you equal results.
Yeah, yeah. And Ernesto Bosch has done a beautiful study. Yes. So as I said, there is the evidence out there, but when you put them all together, and particularly, the ASPIRE trial, which was something that we were all hoping, because it includes almost 1,000 poor responders. It was such a huge effort, and it was actually sponsored by Merck. So it was, a really, really commendable and remarkable project. And, credits to Merck, despite the fact that the results did not prove what they, thought it would be the case, they still published the study, and it still has contributed to our understanding. And I think that's very important in terms of science and in terms of integrity and making sure that we do what is best for science and our patients.
That's really good. There's one more question from Dr. Palak. It's an out-of-course question, but while using decapeptyl trigger, should we cross-check its efficiency so that we do not end up in empty follicle syndrome?
Thank you. So I use decapeptyl trigger a lot when I do freeze-all cycles, and nowadays probably about 40% of my practice is freeze-all cycles. And the only thing that I look at, and that has been shown by a number of studies, including some studies from Brussels, from Christophe Bloquiel and Dr. Popovic-Sodorovitz, is that the basal LH levels seem to be the most significant predictor. If you have a basal LH in an antagonist protocol, a day 2 LH of less than 2.4, some people say less than 2.8, then you should be careful. Obviously, you should be very careful with avoiding hypo patients. And the other very interesting scenario that I would urge you to be very cautious is women that have been on the pill for many, many months, and then they stop the pill and they go to stimulation immediately. They're also at risk of empty follicle syndrome. Whenever I am essentially fearful that that patient might not respond well to decapeptyl, I make sure that early in the next morning, I do an LH, estradiol, and progesterone level and see whether indeed the LH has risen. And if it has, then, in most cases, it's fine. In almost every case, it's fine. I'm yet to see a case of true empty follicle syndrome if you apply the approach and the strategy that I just described.
So thank you for answering, but is it the follicular output ratio is the same with the decapeptyl trigger as it is with the HCG trigger?
Well, the randomized control, that is my impression, but the randomized control, but it's not about impression, it's about evidence. So there is a study by Har et al. Published in, I think, Frontiers in Endocrinology. It's a systematic review and meta-analysis comparing GnRH agonist and ACG, where you can see the number of oocytes retrieved. And because these are randomized controlled trials, if the follicular to output ratio was different, that would have actually translated into different number of oocytes retrieved, and they found absolutely no difference. So I do think, and my personal impression, as I said, based on a very good number of cases over the past few years, I haven't seen, cases where I feel that, if I had given ACG, things would have been different. I know that's a very, very common fear of doctors, and even here, many of my colleagues were very, let's say, reluctant to use agonist triggering because they fear of what you're suggesting. But both the evidence and, in this case, my personal experience suggests that that should not be a problem, especially if you approach things the way I've just told you. Make sure you monitor the LH, you know exactly the basal LH, know where you're using it, and whenever in doubt, always measure LH and progesterone the next morning.
So how many times do you repeat the LH test?
No, just 8 to 12 hours after they get triggered, the next morning.
Thank you, sir.
And if that
so
LH, if that LH is more than 30, it's absolutely fine. And usually we see a spike in proj as well. But the key thing is, because whenever we give the the agonist injection, the LH will start being secreted within an hour or two, and it will reach its peak in about 8 hours. So if you measure it in 8 to 12 hours, you'll see whether there has been an LH peak or not.
Thank you, sir.
Thank you.
Dr. Uma Bansal is asking about, what about dual trigger?
Thank you. I think it's an interesting concept. And I wasn't a big believer a few years ago when I first came across it. And we also did a small retrospective analysis with one clinic in Athens that I was collaborating, research-wise in the past, and did not really find significant differences. But I'm aware of both the RCTs and a couple of systematic reviews and meta-analysis that suggest that particularly in poor responders is beneficial. And I am, I have been converted in a way, so I do use it. Again, not in all cases. In cases where the Ford previously has been suboptimal, or in cases where the oil quality has also not been great. It's one of those scenarios, Dr. Patel and dear colleagues, where because you want to make sure you've done everything you could about the patient, you will obviously add the LH, but then you'll make sure if they are safe to add both triggers, that you would add both triggers, trying to cover all bases and trying to say that at least we've done the things that we've done. It would be great if we had fantastic evidence base so that we know, what patient needs X and what patients need Y and Z. But in many cases, in real clinical life, in real clinical practice, you need to make these educated decisions on the basis of the best available evidence you have.
So there's an interesting case from Dr. Nikita. I had a patient first cycle with Gonalef 300 for 10 days and 2 M2 follicles.
Mature, yeah.
2 mature follicles retrieved. The next cycle, they started with parvovirus, no growth after 8 days, and estradiol was less than 28 on the 8th day. Reason?
Yeah. What was her AMH? To me, that seems like a very, like a poor responder, which, despite the high dose, you couldn't get any more than 2 follicles. And the next cycle, especially if it was back to back, unfortunately, the ovary had nothing to give. So what was the basal FSH? Was it like more than 14? What was the antrofollicle count? What is that woman's AMH? This is the type of responses that I've seen in my practice whenever I have what I call extreme poor responders. And, you always counsel these individuals and say that there is a likelihood that, we might get no response and your ovaries might need to rest. Many times, Dr. Patel, and I'm pretty sure you agree with me, us doctors think that because we can control so many things, we can control everything. Therefore, by adding all the different medications, we can all of a sudden bend the will of the ovary, and bend the ovary to our will in a way. But if there are no follicles there to be stimulated, they will not be stimulated, whatever you add. So that's why
her AMH level was 0.03, very low, and her AFC was 2 to 3 follicles, and I had given her 3 months break between the first and the second protocol. So first time I did get 2 M2s, but no embryo, still blastocyst, and she is 32 years old. She has even injected PRP 2 cycles. She wanted to try with the ovarian regeneration. Nothing worked on these patients. Her FSH is 15.
Yeah. So, as I said, I think this is a classic case of a very poor ovarian responder. And AFC is something that I also measure when I treat these patients. And many times I select the cycles where I would, essentially try and stimulate. If I see that on day 1 or day 2 of the cycle, I cannot see any antral follicle, it's very rarely that I would start injecting patients. I would just tell them, let's just wait and see next month, maybe we're luckier. But even in some cases where I do think I saw 2 follicles or 3 antral follicles, then I might stimulate even up to 450 and nothing comes out. We know that even amongst experienced operators, measuring antral follicles, it's essentially an exercise. You might be just looking in empty space. You don't really know whether there's a follicle there. So it's a matter of potentially trying again next month or the month after that. I don't think there's anything else happening here, to be honest.
There is Dr. Palak asking, do back-to-back stimulation give poor results?
They could. It depends on how I personally avoid them as much as I can. The main reason being because when I do my collections, I'm very thorough. There are many of my colleagues that they will go in and they will just aspirate only the large follicles, the ones that are 14 millimeters or greater, particularly the ones that are a bit more old school, as I say. I'm someone who goes and aspirates every single follicle that I see. And that means that many times I will also aspirate follicles that contain just GVs and they were destined to mature and potentially be stimulated in the next cycle. So, in my own personal practice, because I know my good or bad habits, I avoid it. And I've seen that the number of eggs, whenever I had to do it, I've seen that the number of eggs in back-to-back cycles in the second cycle was almost always, significantly lower than the first cycle. But that's in my practice.
There is Dr. Roshini asking, is dark granulation in ooplasm related to the dose of recombinant FSH, high dose, more granulation? And biosimilar.
Yes. So I do not think so. I think in most cases, it's just the cycle that this woman and the eggs that this woman has to produce. It's more cases idiopathic rather than high doses or prolonged stimulation. Because another theory is if you have prolonged stimulation, then you could lead to very dark oocytes or to oocytes with more granulation. I'm not sure. What about you, Dr. Patel? Do you have a view on this topic?
Yeah, even I feel that higher dosage I try to avoid, but if I've given a higher dose, I'll try to correlate that, okay, because I gave that. The second cycle also, after 2 months, after giving all supplements, and you just take with a lower dosage. And again, the complaint is the same, that the ooplasm are granulated. That means it is the inherent genetic profile of the patient which is giving the dark ooplasm.
Thank you. No, that is my impression as well.
So that was quite interesting. I don't think anybody coming up with any more questions. So if we were to conclude for this clinical outcomes in the real world for polytropin alpha, biosimilar versus originator, I would like your comment for the day, Dr. Christos.
First of all, I would like to say that it really has been, a great privilege and pleasure to be participating in this discussion. And again, I would like to thank you, Dr. Patel, for your coordination and all your knowledge and expertise that you shared with us. And I would like to thank, obviously, Merck. If I were to summarize, I think what we discussed today is the fact that whenever we're making clinical decisions, we should be always looking at the evidence. And one anecdote story that I say sometimes is when we began this journey to compare biosimilars with originator, we were almost all of us convinced that there's going to be nothing there. And we're just going to prove that, yep, they're biosimilars, and having the same number of eggs or similar number of eggs means that you have similar live birth rates. So we were quite surprised with the results that we found. And that once again taught me as a researcher that you should never take things for granted. And any hypothesis you might have, however mundane it might look or implausible, you should still try to explore it. Obviously, as I said, we need more evidence to try and prospectively identify the reasons behind these differences. The original RCTs did not have any real data on embryo quality. I highly value your contribution, Dr. Patel, in terms of the study you have shared with us, because I think that potentially provides a good explanation. And in the future, I hope that I will be able to see and participate in research projects that will be able to clarify the mechanisms a bit more. Until then, I think all of us have, essentially a duty of care to discuss the evidence with our patients. And if the patients want to use product A or product B after they've been properly informed, and obviously following our advice as well, because we're the doctors, then so be it. I think that's the best thing we can do, all of us trying to practice evidence-based medicine.
Thank you, Dr. Christos. It was wonderful. Thank you, all the panelists. It was really a wonderful, interesting session. And it was very nice to have it very interactive so that even we know what is going on and how we can solve all the questions. So with that, I hand it over to Dr. Someshwar. And thanks once again to Merck for having this wonderful program.
Thank you, madam. So it was really wonderful and enlightening. So thank you, Dr. Christos. It was really wonderful to have you. It was a very comprehensive, beautiful session. And also thank you for patiently addressing all the queries from participants despite the time gap between India and Sydney. It was wonderful to have you. Thank you very much, Dr. Nitis. And also thank Dr. Lena Patel, madam, for her wonderful moderation, sharing a unique experience from our own center, and also patiently addressing all the queries despite having a bad throat. So thank you, madam. Thank you for being today. Thank you very much. And thank you, Miranda, for joining. She's our regional medical director from Perth, Australia. She's here. And thank you very much for joining. It was really nice to have you. And last but not the least, thank you all the participants who have joined in on a working day afternoon, and they have put up all the interesting questions, important questions to make this session a very interactive one. Thank you very much. And we look forward to seeing you all once again soon. Thank you very much.
Thank you. Thank you all. Have a good afternoon.
Thank you.
Thank you.
Have a nice
Thank
evening.
you.
Thank you very much. Bye, Miranda. Thank you. Thank you for joining.
Thank you, Samesh. Fantastic evening. Great conversation. Great interaction.
Yes. Great to have you. Thank you.
Have a great weekend, everybody. See ya.
You too. Yeah.
Bye.
Goodbye.